how to design a high available Kubernetes control plane. And when you want to do that, the first thing that you begin with is setting up a cluster of etcd or etcd nodes with 2n plus 1 formula. That is, if you want to tolerate one node failure, even if one node goes down, your cluster shouldn't be affected. You need to have at least 3 nodes to be set up. So 2n plus 1, 2 into 1 plus 1 is 3. And for 2 node failure, it would be 5. And it increments in the 7 and 9 and so on and so forth. And etcd talks to each other. These nodes talk to each other using the Raft consensus protocol. And once you have those etcd nodes set up, then you can create 2 or more instances of rest of the control plane components. So rest of the control plane components include your typically API server, the scheduler, and the controller managers. And how you can place them is you can actually set up 2 master nodes, and along with rest of the components, you can have etcd runnings on those 2 nodes which participate in the etcd cluster as well. Now, what about the third etcd node? One of your client nodes or the worker nodes, the nodes itself, as it is called in Kubernetes environment, can also run etcd. So you can set up 2 masters essentially, and then run etcd, 2 instances of etcd there, and you can have one of the nodes also run etcd for you. And in a really large scale clusters, you can have separate instances running just the etcd, and your API servers on each of your master can connect to the etcd itself. And then you can add any number of nodes to your cluster. And then you can, whenever you need more instances, you can just scale by adding the nodes to your pool. This is a high available setup because even if one of the master goes down, there would be at least 1 master and 2 instances of etcd available for you, which guarantee you the high availability here. Now, if you want even more high availability, you can add 5 instances of etcds and possibly 3 or 4 masters as well. And those masters can also be put behind a load balancer so that all your clients talk to just one host name or the IP address, and from there it goes to whichever master that is available. As far as etcd is concerned, it's the API server which talks to the etcd, so you don't have to bother about connecting to etcd from outside world. Your kubectl or any of the client can talk to the load balancer, and from there it goes to the master. In addition to these configurations and this environment, you also need additional things such as storage and the observability systems, which are typically is what you need in a production grade cluster. Because once you start deploying your microservices, and your containers can run on any of the nodes, and when you redeploy the containers, they can be moved to another node as well, in which case you need some sort of a typical network storage available in your cluster. And in terms of the availability, we talk about 3 different systems in terms of observability. That is, one is the metrics, second is the logs, third is the traces. This is basically to monitor everything and to provide you with some insights which are useful for you to understand what's happening with your cluster and to debug it further as well. Metrics are typically your monitoring systems, and the most popular metrics collector and observability tool here is Prometheus along with Grafana. So you can collect metrics from the system, from the containers, from your services, and see how you're doing, how much of latency is there, what is the disk space, what is the CPU utilization. That's all can be looked at by using the metrics or tools like Prometheus. Then you need logs for sure, because whenever you deploy your containers, the containers are typically immutable, which means that whenever you deploy a new version of your application, the previous containers are going to get deleted, in which case your logs might also go away. So if you want to have your logs persist, you need a system which collects it and stores it somewhere, indexes it, and on top of that, having some sort of a visualization would also be useful, because if you want to find out how many 400 errors or 4xx errors you had, how many 2xx messages you had. If you want to find out how many instances of a particular error happened in the last 24 hours, you can get all those insights, and you can do it from one place, and you get those visual data using the log collector and manager, centralized log management system such as Splunk, or a very popular open source stack called as ELK, Elasticsearch Logstash Kibana. It's new. The new version of that is also EFK. So a slightly changed version of that is Elasticsearch Fluentd Kibana. Fluentd is the one which collects the logs and sends it to your Elasticsearch, which is an indexing engine, and then you have Kibana, which is the UI part of it. And then you have those traces. The traces are especially useful for debugging your microservices based architecture, because if you want to find out how your request traveled between one service and another, how long it took between those two services, which is gonna be very useful when you want to find out when your application slows down and or has performance issues, which span has an issue, which application has an issue. If you want to pinpoint that, using the distributed tracing system is extremely useful. Tools like Jaeger are quite useful and upcoming, especially with the concept of service mesh. Like Istio and so on, that has become an important aspect of it. So what I'm talking about is not just the high available Kubernetes environment, but also a production cluster, which not only needs the cluster Kubernetes high availability components, but also need these auxiliary systems and the tools in order for you to manage your environment and make it work properly. And that's the high available Kubernetes environment for you.